TCP is a connection-oriented protocol. This means that before the data is sent, it is necessary to first set up the connection. And in a similar fashion, once the data has been transmitted, it is necessary to tear down or to terminate the connection. Now, let's go and see what are the steps that should be followed in order to set up the connection. The first thing is that before setting up the connection, for sure there is a client entity and then there is a server entity which have a client application and a server application that run locally. The first step is that the server will perform a passive open function, which basically means that it will inform its local TCP that it is ready to accept new connections. In the same fashion, the client will perform an active open session or active open function because it wishes to communicate with the server or to download or access a certain information, certain data on the server side. Once the passive open is performed and the active open is performed on the server and the client side respectively, the third step is the one that the TCP will randomly select an initial sequence number. So from the client side, the client will send a segment in which the SN, which stands for the sequence number, will be set or given to a random value, and it will send a synchronized type of TCP segment. This synchronized type means that the SYN flag in the header is set to 1. This type of segment is sent when the client wishes to notify the server that it wishes to establish a connection. In fact, among other information that are sent, it provides also other parameters such as the maximum segment size. In fact, this whole thing of having an initial sequence which is random is very useful because it's possible to have connections between two sockets which are closely timed. So by randomly selecting initial sequence for each TCP connection, then it is possible to distinguish one TCP connection with another one which is done in a different moment in time. Then when the TCP, from now on the server side, will receive the synchronization message, it will also randomly select an initial sequence number, in this case sequence number 5608, and it will send a synchronization acknowledgement segment in which the synchronization and the acknowledgement flags are set to 1, which also contains the AN or the acknowledgement number. As you can notice, in this case, the AN is 67804, which is one number higher than the previous sequence number that was sent by the client, which was 67803. So as we have defined for the TCP, the receiving side will send a TCP segment in which it identifies the number of the next byte that it expects to receive. So again, the AN stands for acknowledgement number. In this case, it's given or is denoted as 67804, and then the synchronization number is 67803 on the side of the client that has been sent before. So the whole idea of this is that the acknowledgement which is sent from the server to the client is saying that I know which is the next byte that you should transmit. Now the fifth step is the fact that the TCP client, once it has received the synchronization acknowledgement message from the server, it will send an acknowledgement. In this case, the acknowledgement number is 5609, which is one higher than the one which it received from the server. In fact, what happens is that in this case, the client, it will insert the first data of the connection into the payload with the SN of the first byte. In this case, the SN is 67804, which is the same as the one indicated previously by the server, saying that I expect that the next byte that you will send has this unique ID. Then once this has been completed, the 6th and the 7th step are the one in which the client TCP will notify the application that the connection is open. And on the other side, also in the server, the TCP receives an ACK, and it notifies the application that the connection is open. So all of these steps were necessary for identifying or for notifying the client application, the server application, that the TCP connection has been established. Now, here we notice and we see all of the steps together. So from the passive open to the active open, to the synchronization message, to the synchronization acknowledgement message, up to the acknowledgement message sent from the client to the server. In fact, this exchange of messages is known as three-way handshaking. It's called three-way handshaking because we notice that there are three messages that need to be exchanged between the client side and the server side. In fact, the connection setup messages consume 1 byte, in this case the acknowledgement number in step 4 and the acknowledgement number in step 5, in which we send the information back and forth between the client and the server. So once this has terminated or finished, the data can then be sent from the client to the server or vice versa. And once the data sending finishes, the next step is the termination of the connection or the teardown of the connection. The logic is again the same. What happens is that the TCP that wants to close the connection will send a type of segment which has the FIN type flag set equal to 1 with the last data that it sends. And in this case, the TCP on the other side will send an acknowledgement to confirm the closure. In this case, we see that the client has sent a message through which it says that it wants to terminate the connection, and the server will send an acknowledgement to say that I have acknowledged and confirm your request to close the connection. However, in this case, it might be possible in certain cases that the server still has remaining data to send. In this case, we see that from the server application, from the server side, we see segments which are being transmitted towards the client. Once this is completed, or as soon as the transmission will be completed, then the TCP will close the connection by sending another message which has the flag set to 1, the flag which identifies closing of the connection. And the TCP that initially has asked for closing the connection will send an acknowledgement. In this case, we see that the server side will send a message with the FIN message set with the flag set to 1, and the client side will acknowledge the fact that it has received this type of segment and the connection is therefore teared down or terminated. Again, here we see the various steps that are needed between the client side and the server side in order to tear down the connection. Here we can see that also the connection teardown may use the concept of three-way handshaking by using steps 1, 2, and 4. It is also possible to reset the connection. In fact, the reset of the connection can be done by just simply resetting the flag, which is called RST flag. If this flag is set to 1 in the TCP header, then once one entity, either the receiving side or the transmitting side, I mean either the user or the server, receives a TCP segment which has the reset flag equal to 1, then the TCP will just close the connection, stopping any further data transmission between the user and the server.